talk about having an inverse. Not every function has an inverse. It just doesn't happen all the time. That's why we use that verification to check to see if it did. So in order to know that you have one, you have to be a one-to-one function. And that's what this is saying here. To have an inverse, it must be one-to-one. And you know how we did the vertical line test to find a function? That means if you have an inverse, it has to pass the horizontal line test. Make sure you cover that right now, Joe. Or in other words, if you plug in an A and you plug in a B and they're the same value, that means that the A and the B had to be the same. Okay? And I'll show you what that is in just a moment here. So let's say, just for example, I'm looking at a function, just to kind of give you an idea what this one-to-one thing means. Let's say I'm looking at y equals x squared. And if I draw a picture of that, I know that my picture looks something like this. And they said just a little bit ago that it has to pass this horizontal line test. And what that means is it's like our vertical line test. It means I'm only supposed to hit it once. So did it pass the vertical line test? No. What does that mean for us? What that means is that there's more than one x value that can produce the same y value. For example, if I said, holy moly, let me pause for a second. Okay, back from the technical difficulties. So I notice that this thing hits in two spots. If you guys would like to talk while I'm talking, get out. Stop being disrespectful. So these are the 2 points that I hit right here. And what I want you to notice is, let's just say, for example, that this one over here is -2, and the one on the right is +2. If I plug in to this equation in an x and y coordinate, and I shove in -2 for the x value, and that -2 goes in for x and I square it, I get out 4. And if I shove in +2, out pops 4 again. Or in other words, there are two x values that produce the same y value, and we were saying that that's not allowed. And that's what this part was saying, that if you have two y values, these are the y values, and they're equal, that means that the two x values have to be equal. Well, over here I have my two y values being equal. Here they are. So my y's being equal are right there. But I notice that my x values that are supposed to be equal are not. So that's not one-to-one. And that means that that function does not have an inverse. Algebraically, if you were going to show this, which I don't know is always the best way to make that work. You might recall on the previous page it said that f of A equals f of B means A is the same as B. And we just showed that that wasn't true for the x squared graph. So let's see what happens when we plug this in. Let's look at this 3x plus 5 thing, and let's plug in an A. 3 times A, I'm plugging in the A, plus 5. And that gives me 3A plus 5. Now let's do it for the other one. Let's plug in a B. 3B, so here's the B, plus 5 is the same as 3B plus 5 when I simplify. If I subtract 5 from both sides, I get 3A equals 3B. If I divide both sides by 3, I get A is the same as B. Notice how they both turn out to be the same thing. A is the same as B. Unlike the previous example with the y equals x squared, where you saw that that wasn't true. -2 and +2 are not the same. I flip back there, this is what we did just a second ago. The y values were the same in brown, but the x values were not the same. Did not work out. But just now, with a line, excuse me, it did work out. Two different letters that should give me the same y value if the x values are the same. So the a and b have to be the same in order for that to be true. We're going to skip number 6. Same kind of deal. But in place of number 6, I'm just going to use that y equals again. Let's try it with the a and the b thing this time, just to show you how it works. So let's cancel this out here. Let's just use that y equals x squared and see what happens. So first time I plugged in an a, and it's being squared. And then the second time I'm plugging in a b, and it's squared. And if this two things are the same, then the a and the b should be the same thing, right? So I know that I now have a squared equals b squared. So in order to get to a and b, I have to square root. So I square root both sides, because I know that's what I'm supposed to do. And every time you square root a variable,
two answers.
You get two answers. So plus or minus a could be equal to plus or minus b. And what that's saying is, pick a number for a, like 2, for example, and my positive 2 would be equal to my negative 2, and that doesn't make any sense. And I don't know which one's which at any given time. And that's why I know that this thing is not going to be a one-to-one function. Not going to have an inverse. Whenever you get plus or minus, that's a big no-no.
Square.
So this graph, if I was doing the y equals x squared, would look like this. The one that we just got done crossing out that I didn't do is really the same thing. It's just moved over. It's the same thing. I just want to do one with less algebraic stuff involved. Sam?
Well, what about the domain thing with x being less than or equal to 5? What?
So if they eliminate half of the parabola, for example, in the x minus 5 one, if they say it's got to be greater than or equal to 5, I know that this stuff is gone. So the only part that exists in the gray parabola is the right-hand side. And if I draw a horizontal line, now I'm only hitting that gray graph in one spot. It could have an inverse, that's fine. And so that's what they're talking about. There won't be any plus or minus anymore because it's only the positive values that are showing up that way when you flip it, or only the negative values if it's flipped the other way. All right, 2 more examples. I thought we would do ones that were a little more difficult, quote unquote. Remember, the big idea is switch x and y, number 1, and then number 2, solve for y. This is to find an inverse. And I told you that I like to use y instead of f of x. So I'm just going to change this equation into y equals the cube root of x minus 5. Not that you have to do that. It's just something that for me, I grew up having y's and x's. Was very comfortable with that, so I like to start that way. So the first thing I'm going to do is I'm going to switch the x and the y. So now I have x equals the cube root of y minus 5. Oh no, I have to solve for the y, and I have a cube root, so I'm going to cube it both sides. So I cube both sides, and I get x cubed equals y minus 5. Oh look, there's no more root symbol anymore. Just get rid of the 5 by adding 5 to both sides. And I end up with y equals x cubed plus 5. That's my inverse. I probably should write it like this. The reason they use that f minus 1 thing is to distinguish the inverse function from the original function, so that there is no doubt which one's which.
On the test, are you going to want us to write it that way?
Yes, I always model what I want to see. Mason, stop looking at my butt. Letter B. Doesn't matter if it's F or G. F and G, same thing. I'm going to start out with y equals x minus 4 all over x plus 2. Bless you. What's different about this problem compared to all the other ones we've done?
Fractions.
Fractions, 2 x's. Okay, very different. Strategy is still exactly the same. Switch the x and the y, solve, but we're going to have to be cautious, and I'll show you how to be cautious as we do this. So when I switch the x and the y, I now get x equals y minus 4 all over y plus 2. The bummer is, since I have a fraction, I'm going to get rid of that fraction, and I have 2 y's, so I have to figure that out as well. In order to get rid of the fraction to begin with, I'm going to multiply both sides by y plus 2. So I multiply the right side by y plus 2, and I multiply the left side by y plus 2. The whole point of multiplying the right side by y plus 2 is that those y plus 2's reduce. They're gone. Now we don't have any fractions. On the left side, I'm going to have x times y plus 2. That was a group. And on the right side, I just have y minus 4. Bless you. If I distribute the x to the y and the 2, I get xy plus 2x equals y minus 4. And we talked about there are 2 y things now. It's kind of annoying, but super easy to take care of once you know what to do. Always, always, always get all the y things on one side of the equation and everything else on the other. So what I'm going to end up doing is I'm going to end up moving this y to the left-hand side and this 2x to the right-hand side. And the big mystery, of course, is that when you're moving things back and forth across the equation symbol, they change sign. So now on the left side, I still have my xy, but the positive y that was on the right becomes minus y on the left. And on the right side, I had the minus 4. And since I'm moving the 2x from the left to the right, it was positive, now it becomes negative. And now I have my y things on the left side, everything else on the right. What number is in front of the minus y?
1.
A 1. Don't forget that. There is a 1 here. They don't write it down. You need to know that. Oh, look. The 2 terms on the left side have a common factor. A common factor of y. Y times x is xy, and y times negative 1 is negative 1y. On the right side, I still have my minus 4 and my minus 2x. If you divide both sides by the parentheses, x minus 1, you will have left over, of course, y all by itself equals negative 4 minus 2x all over x minus 1. That's your inverse. Don't forget to write it as f minus 1 of x equals, and this is what goes right there.